Okay, so we got to we got to find the derivative, in particular dy dt, given this pair of functions. So if you notice, y is not stated in terms of t. We got to take the derivative with respect to t. It says dy dt, the derivative of y with respect to t. So this is a chain rule problem. In particular, it's one where it's not composed already. Right? Like one way to get dy dt would be to just go ahead and compose it yourself. Right? Everywhere that you see x, you're going to replace x with x's definition in terms of t squared plus 7. So this is one way to do it. And then you would just take this derivative with respect to t. If you notice, you have a chain rule here. Well, we'll do this one as well. We can do it y prime. Let's see, 2 comes down, t squared plus, that is supposed to be a 7. That is a 7, okay. Almost looked like a 2 to me for a second. 7, there we go. T squared plus 7, reduce the power by 1. Derivative of the inside is 2t. And then if you notice, we've got a minus 2t squared if you were to distribute. So, if you distribute that, of course, this minus 14 is going to go away. But the negative 2t squared will give us a negative 4t. And then this here would work as the derivative. Now, another way to do it, and in all actuality, the way they kind of are suggesting to find this is to apply really the chain rule in fashion with the fact that if I were to take the derivative of y with respect to x, right, because that's how y is stated, and multiply it by the derivative of x, which is stated in terms of t, right, the result of that product is another way of getting here, dy dt, right, dy dt, which is what we needed. So let's see, if we do it that way, we can get dy dx by just simply taking the derivative of y, which is 2x minus 2, and then we will take the derivative of x with respect to t, right, which is 2t. So here we have dy dx, 2x minus 2. And we got dx dt, which is 2t. And now this product is the answer. However, we don't want the result in terms of any x's. We need it to be in terms of t, right? That was the derivative in terms of t, dy dt being the variable. So at this point, you would just simply replace x with its definition of t. So we would have 2. And then instead of x, I'm writing what x is, t squared plus 7 minus 2 times 2t. And let's see, if we were to, I don't want to make it look like this because these are the same. They might look a little different. So let's go ahead and simplify this. If you notice, I'm going to have, let's see, 2t squared plus 14 minus 2 is 12. And then there's the 2t. Maybe we can distribute the 2t, and we're going to get 4t cubed plus 24t. Now, if we go over here, we're going to have, let's see, 2t squared times another 2t. So we're going to have this. I like to think of this as 2t times 2 is 4t. So I'm really distributing a 4t in, right? So I got 4t cubed plus 4 times 7 is 28t. And then over here, I've got minus 4t. So if you notice, that's going to reduce to the exact same answer, right? 4t. Oh, you know what? This is supposed to be cubed, right? Because 2t squared times another t. Maybe I meant to write a 3 there, but it looks like a 2 to me. It's supposed to be a 3. But hopefully you see, either way we get the same result, right? This is still going to be 4t cubed plus 24t. So what the book was calling the extended power rule was having this function already composed, right? Meaning, maybe I did have profit in terms of x, and then x's could be units, and then I have units as a function of time. But we could, knowing those two rules, just compose it ourselves and then take the derivative using what the book calls, again, the extended power rule. Or this is just really the full-on, just pure definition of the chain rule, derivative of one function with respect to its variable. As long as we have a definition of that variable in terms of the other, so in this case, like we have a definition of x in terms of t, we can chain them together to get the derivative of y with respect to t by just multiplying them. So and that's just the algebra behind that. So either way, hopefully you get that answer there. And if you have any more questions on this problem, let me know. Thanks. Bye.